On July 20th, 1969, the Apollo 11 lunar module touched down on the moon's surface. Two brave astronauts, Neil Armstrong and Buzz Aldrin, were sent from Earth to hundreds of thousands of miles away to the moon.
Control, we passed the 6-minute mark in our countdown for Apollo 11, flight to land, first men on the moon.
After landing, Neil Armstrong faced his first challenge. The hatch door proved stubborn and difficult to open because of the pressure difference between the cabin and the vacuum of space outside. After some struggle, Armstrong finally managed to get it open. As Armstrong maneuvered to try and leave the shuttle, he accidentally bumped the top of the doorframe. This small bump broke off a crucial piece of equipment. Neither Armstrong nor Aldrin heard the piece break off because sound cannot travel in the vacuum of space. On Earth, we hear sounds because air molecules carry sound waves to our ears. But space has no air, so it's completely silent. This broken piece turned out to be incredibly important. It was the ascent engine arming switch, a vital component needed to start the engine that would lift them off the moon and back to the command module orbiting above. Without this switch, their lunar module would be stranded on the moon forever, and the two astronauts would never return home. But at this moment, they had no idea what had just happened. Unaware of the danger, Neil Armstrong carefully made his way down the ladder and stepped onto the moon's surface. He became the first human being to walk on another world.
It's one small step for man, one giant leap for mankind. Oh, that looks beautiful from here, Neil. It has a stark beauty.
His famous words echoed across space and time. One small step for man, one giant leap for mankind. But here's the question that still sparks heated debates today. Did this incredible moment actually happen? More than 50 years later, millions of people around the world refuse to believe that humans ever set foot on the moon. They create elaborate theories claiming that the entire Apollo 11 mission was an elaborate hoax staged by the American government. They argue that NASA filmed everything on a movie set somewhere on Earth and deceived the entire world. Moon landing doubters point to various pieces of evidence. They ask questions like, how could the American flag appear to flutter when there's no air on the moon to create wind? These questions have created one of the most persistent conspiracy theories in modern history. So, what's the real truth behind this story? You might be surprised to learn that the real reason behind the Apollo 11 mission wasn't scientific curiosity or the spirit of exploration. It was war. Not a traditional war with guns and tanks, but the Cold War between the United States and the Soviet Union. This invisible war was fought with technology, propaganda, and national pride. Both superpowers were locked in an intense space race, each trying to prove their superiority by achieving space milestones first. In 1957, the Soviet Union shocked the world by launching Sputnik, the first artificial satellite ever placed in Earth's orbit. This small, beeping metal sphere was only about the size of a beach ball, but its impact was massive. Americans looked up at the night sky knowing that a Soviet-made object was passing over their heads every 96 minutes. The American government panicked. If the Soviets could put a satellite in space, they could potentially put nuclear weapons there too. This technological achievement demonstrated that Soviet rockets were powerful enough to reach any target on Earth. The United States responded quickly. Just months later, in 1958, America launched its own satellite into space. But the competition was just getting started. 3 years later, in 1961, the Soviets delivered another devastating blow to American pride. Soviet cosmonaut Yuri Gagarin became the first human being to travel to space and orbit the Earth. This 27-year-old pilot spent 108 minutes circling our planet, proving that humans could survive in the harsh environment of space. Once again, the Soviet Union had beaten America to a major space milestone. American leaders were humiliated and desperate to regain their technological reputation. Just 1 week after Gagarin's historic flight, President John F. Kennedy wrote an urgent letter to Vice President Lyndon Johnson. The letter, dated April 20th, 1961, revealed Kennedy's frustration and determination. He asked Johnson how America could beat the Soviet Union in the space race. Kennedy wrote, "Do we have a chance of beating the Soviets by putting a laboratory in space? Or by a trip around the moon? Are we working 24 hours a day on existing programs? If not, why not? Are we making the maximum effort? The president wanted to know if there was any space program that America could achieve quickly, something that would produce dramatic results and give them a clear lead in the race. Kennedy got his answer within days. Space experts told him that the next logical step would be landing humans on the moon and bringing them back safely. This would be far more challenging than anything either country had attempted before. On May 25, 1961, Kennedy stood before Congress and made one of the boldest promises in human history. He declared that America would land humans on the moon and return them safely to Earth before the decade ended. This gave NASA less than 9 years to accomplish something that seemed impossible. Many people thought Kennedy had lost his mind. The Soviet Union had a significant head start and their space program seemed far more advanced than America's. But Kennedy was determined to win this race at any cost. Over the next 5 years, Kennedy provided between $7 and $9 billion in additional funding to NASA. In today's money, that would be equivalent to about $60 billion. The entire space agency focused on one single goal: getting to the moon before the Soviets. Between 1963 and 1967, NASA conducted numerous unmanned test flights. These missions carried no astronauts, instead using instruments and computers to test various systems and procedures. Every test revealed new problems that engineers had to solve. NASA continued with Apollo 4, Apollo 5, and Apollo 6, all unmanned missions designed to test the improved systems. Each flight revealed new challenges and solutions. In October 1968, Apollo 7 finally put astronauts back in space for the first time since the Apollo 1 fire. The mission was a complete success, proving that the safety improvements worked perfectly. Just 2 months later, Apollo 8 achieved something extraordinary. In December 1968, 3 astronauts traveled all the way to the moon, becoming the first humans to leave Earth's gravitational influence and see our planet as a small blue marble floating in the darkness of space. They didn't land on the moon, but they orbited it 10 times, taking photographs and testing navigation systems. 3 months after that, Apollo 9 tested the lunar module in Earth's orbit. This strange-looking spacecraft would actually land on the moon's surface, so every system had to work perfectly. 2 months later, in May 1969, Apollo 10 conducted what NASA called a dress rehearsal for the actual moon landing. 3 astronauts flew to the moon and tested almost everything that Apollo 11 would need to do, except for the final landing itself. They flew the lunar module down to within just 50,000 feet of the moon's surface before returning to the command module. Look at the incredible pace NASA maintained during this period. Every 2 to 3 months, they launched another mission, each one more complex and ambitious than the last. They were testing rockets, spacecraft systems, navigation, communication, and human endurance in the harsh environment of space. After all these careful preparations and tests, NASA was finally ready for the ultimate challenge. On July 16, 1969, Apollo 11 launched from Kennedy Space Center in Florida. 3, 2, 1, 0. All engines running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff of Apollo 11. 3 astronauts were aboard this historic mission. The mission commander was 38-year-old Neil Armstrong, a former test pilot with ice-cold nerves and exceptional flying skills. He had already proven his courage during the dangerous Gemini 8 mission, where he saved his spacecraft from a potentially fatal spin. The command module pilot was Michael Collins, who would remain in lunar orbit while his crewmates descended to the surface. Collins often gets forgotten in history books, but his job was absolutely critical. Without him, Armstrong and Aldrin would have no way to return home. The lunar module pilot was Edwin Buzz Aldrin, a brilliant engineer and pilot who had written his doctoral dissertation on orbital mechanisms. His technical expertise would be essential for the precise calculations needed to land on the moon. The lunar landing was scheduled for around 8 p.m. Houston time, as Eagle began its powered descent toward the moon's surface. Everything seemed to be going according to plan. The onboard computer was guiding the spacecraft automatically toward the predetermined landing site in the Sea of Tranquility. But at exactly 8:10 p.m., warning alarms suddenly began blaring inside the lunar module. The computer displayed error codes 1201 and 1202, numbers that neither Armstrong nor Aldrin recognized. These alarms were so rare that even experienced astronauts had never encountered them during training. 1201 alarm, Armstrong reported to Mission Control, his voice remaining remarkably calm despite the potential danger. Armstrong and Aldrin had no idea what these alarms meant or how serious the situation might be. They immediately contacted Mission Control in Houston, asking for guidance on whether they should abort the landing or continue their descent.
Roger, 12 alarms. Okay, we're go.
Flight side or right on. Real good.
2,000 feet. 2,000 feet. Into the ag, 47 degrees. Roger. 47
How's our
degrees.
margin looking, Bob? It looks okay. We're about 4.5. Roger.
"We're going on that alarm," Mission Control replied, giving Armstrong and Aldrin permission to continue their descent. The 1202 alarm was actually a warning that the computer's processor was working at maximum capacity. But fortunately, the engineers at MIT who designed the system had anticipated this possibility. The computer automatically shed less important tasks and focused on the critical job of landing safely. The lunar module continued its descent using the automatic landing program. But at an altitude of just 500 feet above the surface, Neil Armstrong noticed a serious problem. The computer was guiding them toward a landing site filled with massive boulders and a large crater. Landing there would almost certainly damage the fragile spacecraft and strand them on the moon. Armstrong made a split-second decision that saved the mission. He switched off the automatic system and took manual control of the lunar module. Using his exceptional piloting skills, he flew the spacecraft horizontally across the lunar surface, searching for a safer landing spot. Armstrong finally spotted a relatively smooth area about 4 miles away from the original target and began his final descent. Finally, Neil Armstrong's steady voice crackled across 240,000 miles of space. The Eagle has landed. This historic moment was broadcast live on television to an estimated 650 million people around the world, making it one of the most watched events in human history. His famous declaration, "One small step for man, one giant leap for mankind," became some of the most memorable words ever spoken. About 20 minutes later, Buzz Aldrin joined Armstrong on the surface, becoming the second human to walk on another world. The two astronauts spent the next 2.5 hours conducting what NASA called an EVA, or extravehicular activity, collecting samples of lunar rocks and dust, taking hundreds of photographs, and setting up scientific instruments. The Cold War might have been the driving force behind the moon landing, but NASA made sure to maximize the scientific value of this extraordinary opportunity. The astronauts set up a solar wind experiment to measure the stream of particles constantly flowing from the sun. This device would help scientists understand the space environment and its effects on both spacecraft and planetary atmospheres. They installed a laser reflector, a special mirror designed to reflect laser beams shot from Earth back to their source with incredible precision. This device is still used today to measure the exact distance between Earth and the moon, and it has revealed that the moon is gradually moving away from Earth at about 1.5 inches per year. The astronauts also deployed a passive seismometer to detect moonquakes and meteor impacts. This instrument would help scientists understand the moon's internal structure and geological activity. Surprisingly, the moon experiences thousands of small moonquakes each year, caused by tidal forces from Earth and thermal expansion and contraction. During their exploration, Armstrong and Aldrin collected 47.5 pounds of lunar rocks and soil samples. These samples would be studied by scientists around the world and would revolutionize our understanding of how the moon formed and evolved over billions of years. Before leaving the surface, they planted an American flag and left behind a plaque with an inscription that reflected the peaceful nature of their mission. Here, men from the planet Earth first set foot upon the moon, July 1969 AD. We came in peace for all mankind. But when Armstrong and Aldrin returned to their spacecraft and began preparing for takeoff, they discovered the broken ascent engine arming switch that had been damaged during Armstrong's exit from the lunar module hours earlier. Without this switch, they could not start the engine that would lift them off the moon and back to Michael Collins orbiting above. The two astronauts informed Mission Control about their potentially catastrophic problem. Engineers on Earth began working frantically to find a solution, but they had limited time and even more limited options. The solution came from an unexpected source. Buzz Aldrin realized that an electrical switch is simply a device that completes or breaks an electrical circuit. If the physical switch was broken, perhaps something else could bridge the gap and complete the circuit. Looking around the cramped lunar module cabin, Aldrin spotted his felt tip pen. The metal tip and internal components could potentially conduct electricity. In a moment of brilliant improvisation, he used the pen to manually complete the electric circuit that would start their engine. This improvised repair worked perfectly. The ascent engine fired as planned, lifting the upper stage of the lunar module off the surface and into lunar orbit. The precision required for this launch was extraordinary. They had to reach exactly the right altitude and speed to rendezvous with Michael Collins, who was traveling around the moon at over 3,600 miles per hour. After a successful rendezvous and docking, the three astronauts were reunited in the command module Columbia. They jettisoned the lunar module's upper stage, which later crashed back onto the moon's surface, and began their 3-day journey home to Earth. The risks of the Apollo 11 mission were so great that President Richard Nixon had actually prepared 2 different speeches. One celebrated the successful return of the astronauts, but the other was a somber address to be given if Armstrong and Aldrin died on the moon. This alternate speech, titled "In Event of Moon Disaster," contained these haunting words: "Fate has ordained that the men who went to the moon to explore in peace will stay on the moon to rest in peace. These brave men, Neil Armstrong and Edwin Aldrin, know that there is no hope for their recovery, but they also know that there is hope for mankind in their sacrifice." Fortunately, this tragic speech was never needed. The command module's heat shield performed perfectly, protecting the astronauts from temperatures exceeding 5,000 degrees Fahrenheit as they plunged through Earth's atmosphere at 25,000 miles per hour. The spacecraft's parachutes deployed flawlessly, and Columbia splashed down safely in the Pacific Ocean, where recovery ships were waiting. All 3 astronauts emerged alive and healthy from their incredible 8-day journey. But their adventure wasn't quite over yet. NASA scientists were concerned about the possibility that the astronauts might have brought back dangerous microorganisms from the moon. Although the moon appeared to be lifeless, nobody could be completely certain. The 3 astronauts were immediately placed in quarantine for 21 days, isolated from all human contact in a specially designed facility. They had to live in this sterile environment while doctors monitored their health and scientists tested their blood and the lunar samples for any signs of alien life. This quarantine period proved unnecessary, as the moon contained no life forms that could threaten Earth, but it demonstrated NASA's commitment to planetary protection and scientific caution. The successful completion of Apollo 11 made headlines in newspapers around the world and fulfilled President Kennedy's bold promise to land humans on the moon before the end of the 1960s. In 1969, most people had little reason to question mankind's historic first step on the moon. After all, this achievement was a celebration of technological supremacy and human determination. America had finally won the space race against the Soviet Union, proving that democratic nations could achieve seemingly impossible goals through dedication and scientific innovation. But here's something that makes conspiracy theorists suspicious. Could it be possible that America, desperate to gain an advantage in the Cold War, actually planned a fake moon landing operation? Maybe their real moon landing mission failed, and they created this elaborate hoax as a backup plan to fool the world and claim victory in the space race. However, the truth is that these conspiracy theories have been thoroughly debunked by scientists, engineers, and historians multiple times over the decades. The evidence supporting the moon landing is overwhelming and comes from multiple independent sources around the world. If this had been a fake attempt by America to deceive the world, their biggest rival, the Soviet Union, would never have acknowledged it. The Soviets had every reason to expose American lies and claim propaganda victory for themselves. They had been losing the space race and would have jumped at any opportunity to embarrass the United States. But look at what actually happened. The Great Soviet Encyclopedia, published between 1970 and 1979, in its 3rd edition, acknowledged the moon landing as factual multiple times. This wasn't just a brief mention either. Soviet scientists and journalists wrote detailed articles stating that the Apollo 11 landing was the 3rd most historic event of the space age. According to Soviet experts, the first historic event was Sputnik's launch in 1957, which started the space race. The second was Yuri Gagarin's flight in 1961, when he became the first human in space. And the third was the American moon landing in 1969. The Soviet Union, America's greatest enemy at the time, officially acknowledged this achievement as real and historically significant. But conspiracy theorists still point to various pieces of evidence that they claim prove the landing was staged. Let's examine their most common arguments and see what the real explanations are. The most famous question conspiracy theorists ask is about the American flag planted on the moon's surface. They argue that the flag appears to be fluttering in the wind, but there's no air on the moon to create wind. This seems like a valid point until you understand the real engineering behind the flag. The flag that Armstrong and Aldrin took to the moon was not a normal flag like you might see flying outside a building on Earth. NASA engineers knew that a regular flag would hang limp and lifeless in the vacuum of space, making it impossible to see properly in photographs and television broadcasts. To solve this problem, they designed a special flag with 2 support rods instead of just 1. Normal flags have only 1 vertical pole, but the lunar flag also had a horizontal rod running along the top edge. This horizontal rod was designed to keep the flag fully extended and visible at all times. However, during the actual Apollo 11 mission, the astronauts encountered some technical difficulties when trying to fully extend this horizontal rod. The mechanism didn't work properly and they couldn't get the rod to extend completely to its designed length. This created wrinkles and waves in the flag's fabric that remained frozen in place. The fluttering that conspiracy theorists see in videos only occurs when the astronauts are physically handling the flag and moving it with their hands. The aluminum rods supporting the flag acted like springs, so when the astronauts touched or adjusted the flag, it would vibrate and move for a few moments before becoming perfectly still again. You can actually observe this in the original NASA footage. The flag moves only when the astronauts are near it and touching it. When they walk away, the flag becomes completely motionless and stays that way. In the vacuum of space, there's no air resistance to gradually slow down the movement, so the flag oscillates for a longer time than it would on Earth. Another popular conspiracy theory focuses on the photographs taken during the moon landing. Critics point out that stars are not visible in any of the pictures, which they claim proves the photos were taken in a studio with artificial lighting. The explanation for this is actually quite simple and has to do with basic photography principles that any professional photographer understands. The moon landing took place during the lunar day, when bright sunlight was illuminating the moon's surface. The astronauts were wearing bright white spacesuits that reflected enormous amounts of light. The lunar surface itself, despite appearing gray, was also reflecting intense sunlight. All of this reflected light was much brighter than the distant stars in the background. The cameras used during the Apollo mission had limited dynamic range compared to modern digital cameras. They were designed and calibrated to properly expose the bright surfaces of the spacesuits, equipment, and lunar terrain. To capture these bright objects clearly, the camera settings made the much dimmer stars invisible in the background. This is exactly what happens when you try to take a photograph at night with your smartphone's flash turned on. The bright flash illuminates objects in the foreground, but the camera's automatic settings make background stars disappear from the image. Even today, with much more advanced camera technology, it's difficult to capture both bright foreground objects and dim stars in the same photograph without special techniques. Professional photographers and astronomers have replicated this effect countless times, proving that the absence of stars in moon landing photos is exactly what you would expect under those lighting conditions. Conspiracy theorists also question the shadow visible in lunar photographs, claiming that the shadow points in different directions, which would be impossible with only one light source like the sun. They argue that this proves multiple studio lights were used to stage the photographs. But this argument misses an important fact about the lunar environment. While the sun was indeed the primary light source, it wasn't the only source of illumination on the moon's surface. The lunar surface itself acted as a massive secondary light source by reflecting enormous amounts of sunlight in all directions. Think about how a light behaves when you shine a flashlight on a white wall in a dark room. The wall doesn't just absorb the light, it reflects it and illuminates other objects in the room. The same principle applies on the moon, but on a much larger scale. The moon's surface is covered with a fine light-colored dust called regolith that reflects sunlight in many directions. This creates what photographers call fill light, that softens shadows and illuminates objects that would otherwise be completely dark. Additionally, the lunar landscape isn't perfectly flat. There are subtle hills, crater rims, and rocks that reflect light at various angles, creating complex lighting patterns that can make shadows appear to point in different directions. Professional photographers have recreated these exact lighting conditions on Earth to demonstrate how natural lighting can produce seemingly impossible shadow patterns. Another frequently cited piece of evidence involves a photograph of Buzz Aldrin taken by Neil Armstrong. In the reflection visible in Aldrin's helmet visor, you can see Armstrong, but some people claim you can also see a camera in his hands. They argue this is impossible because Armstrong was supposedly taking the picture. The real explanation is much simpler than conspiracy theorists suggest. Armstrong wasn't holding a handheld camera when the photo was taken. Instead, the camera was mounted directly on the front of his spacesuit, a system called a Hasselblad chest-mounted camera. He could control the camera's settings and trigger without using his hands, leaving his hands free for other tasks. This chest-mounted camera system was specifically designed for use during spacewalks and surface operations, where astronauts needed to take photographs while keeping their hands available for more important tasks, like collecting samples or operating equipment. But conspiracy theorists ask another question. If Armstrong's camera was mounted on his chest, then who took the photographs and videos of Armstrong himself descending from the lunar module and taking his first steps on the moon? Again, the answer is straightforward. The lunar module was equipped with multiple cameras installed in various locations on the spacecraft's exterior. These cameras were positioned to capture important moments like the astronauts' exit from the spacecraft and their initial activities on the surface. One camera was specifically mounted near the lunar module's ladder to record Armstrong's historic first steps. Buzz Aldrin, who was still inside the spacecraft at the time, could control some of these cameras remotely. Later, when Aldrin joined Armstrong on the surface, they worked together to operate the cameras and document their exploration. These technical explanations demonstrate that conspiracy theorists often lack understanding of the actual equipment and procedures used during the Apollo missions. NASA's engineering solutions were elegant and practical, designed to work in the unique environment of space and the moon's surface. Moving beyond these easily debunked conspiracy theories, it's important to acknowledge that not everyone was celebrating NASA's achievement after the moon landing. There was actually significant legitimate criticism of the space program, both before and after Apollo 11. Many people strongly criticized NASA and the American government for spending enormous amounts of money on space exploration while the country faced serious domestic problems. This criticism came from respected journalists, economists, politicians, and ordinary citizens who questioned the government's spending priorities. In January 1962, 7 years before the moon landing, the New York Times published a thought-provoking article that put NASA's budget into perspective. The newspaper calculated that the money being spent on the moon program could have been used to build at least 120 universities the size of Harvard. This raised important questions about national priorities. Should the government spend billions of dollars to send a few people to the moon? Or would that money be better spent opening a Harvard-sized university in every American state? Wouldn't such an investment in education provide more long-term benefits for society? The criticism became even more intense as the 1960s progressed and America became increasingly involved in the Vietnam War. By 1969, the country was spending enormous amounts of money fighting an unpopular war, while also funding the expensive space program. Many Americans wondered why their government was spending so much money on these projects, while neglecting education, healthcare, poverty, and racial inequality at home. Civil rights leaders like Ralph Abernathy organized protests at NASA launches, arguing that the space program represented misplaced priorities. They pointed out that while America could send men to the moon, it still couldn't guarantee basic rights and opportunities for all of its citizens on Earth. But despite these valid criticisms, the moon landing actually produced many hidden benefits that nobody had anticipated at the time. These unexpected technological advances would eventually transform modern life in ways that even NASA's planners hadn't imagined. One of the most significant benefits was the advancement in computer chip technology. In 1962, integrated circuits, or microchips, had only been invented 3 years earlier, and most major computer companies were skeptical about their reliability and usefulness. IBM, the world's leading computer manufacturer at the time, had actually decided in the early 1960s that they wouldn't use these new microchips in their computers. They considered the technology too experimental and unreliable for serious applications. But NASA took a different approach. The space agency needed computers that were much smaller, lighter, and more reliable than anything available at the time. Traditional computers were enormous machines that filled entire rooms and consumed massive amounts of electricity. These room-sized computers were obviously impossible to fit inside a spacecraft. NASA decided to bet heavily on the new microchip technology, placing enormous orders for integrated circuits from various manufacturers. This sudden, massive demand had several important effects on the entire computer industry. First, the high-volume orders allowed chip manufacturers to invest in better production techniques and quality control procedures. They had guaranteed customers for their products, which gave them the financial security needed to improve their manufacturing processes. Second, the large-scale production drove down costs dramatically. Because of NASA's heavy demand, the price of integrated circuits fell by more than 90% over the next 5 years. This price reduction made microchips affordable for many other applications beyond space exploration. Third, NASA's rigorous testing requirements proved that microchips could be reliable enough to trust with human lives. If these computer chips could safely guide astronauts to the moon and back, then obviously they could be trusted for less critical applications in everyday life. This validation by NASA gave other industries the confidence to adopt microchip technology for their own products. The space program essentially served as a testing ground that proved the reliability and usefulness of integrated circuits for the entire world. The technological advances stimulated by the moon program grew exponentially after Apollo 11's success. Computer technology, materials science, telecommunications, and countless other fields all benefited from innovations originally developed for space exploration. However, despite these long-term benefits, public enthusiasm for the space program began to fade quickly after the initial excitement of the moon landing. Only 3 years after Apollo 11's triumph, in December 1972, the final moon mission, Apollo 17, took place. Since then, it has been more than 50 years, and no other human beings have traveled to the moon. This long gap is perhaps the biggest proof of just how expensive and technically challenging the Apollo program really was. The Apollo program employed more than 400,000 engineers, scientists, and technicians at its peak. These weren't just NASA employees. They worked for hundreds of contractors and subcontractors across the entire United States. The program involved virtually every major aerospace company, university research department, and technology firm in the country. The total cost of the Apollo program was approximately $24 billion in the 1960s. To put that into perspective, that amount would be equivalent to more than $150 billion in today's purchasing power. This made Apollo one of the most expensive peacetime projects in American history. Initially, criticism of the space program came primarily from journalists and intellectuals who questioned the spending priorities. But by 1972, the average person's fascination with NASA and the moon exploration had largely ended. The Vietnam War was still raging, and American society was dealing with numerous serious problems, including racial tensions, economic inequality, environmental pollution, and social unrest. Citizens increasingly viewed the space program as an expensive luxury that the country could no longer afford. Thousands of demonstrators regularly protested against the Vietnam War, and many of these protesters also criticized government spending on space exploration. They saw both the war and the space program as wasteful uses of taxpayer money that should instead be spent on education, healthcare, housing, and other domestic priorities. Politicians had to respond to this growing public sentiment. Even though NASA had originally planned missions through Apollo 20, political pressure forced the cancellation of the final 3 missions. The money that would have been spent on these lunar expeditions was redirected toward other government programs that addressed more immediate social needs. In December 2017, former President Donald Trump announced that he would increase NASA's funding so that humans could return to the moon by 2024. He declared that American astronauts would return to the moon for the first time since 1972. This time for long-term exploration and permanent bases rather than just brief visits. But later, Trump changed his position and suggested that NASA should focus on Mars exploration rather than returning to the moon. This shift reflected ongoing debates about the best direction for America's space program and how to allocate limited resources among competing priorities. However, 50 years after Apollo 11, NASA has once again made concrete plans to send people back to the moon through their new Artemis program. This ambitious project represents a completely different approach from the original Apollo missions. The Artemis program will begin with unmanned test flights to verify that all systems work safely before risking human lives. These robotic missions will test new spacecraft design, landing systems, and life support technologies that are much more advanced than anything available during the 1960s. NASA currently plans that by 2025 or 2026, the Artemis program will achieve several historic milestones. They intend to send the first woman to walk on the moon's surface, breaking the barrier that limited the original Apollo missions to male astronauts only. Additionally, NASA plans to send the first person of color to the moon, reflecting the space agency's commitment to diversity and inclusion. The original Apollo crews were composed entirely of white male military test pilots, but the modern space program draws astronauts from much more diverse backgrounds, including different races, genders, and professional specialties. Their new lunar mission will be fundamentally different from Apollo in their goals and scope. Instead of brief 3-day visits, Artemis aims to establish a permanent human presence on the moon with long-term bases that could support scientific research, resource extraction, and eventually serve as stepping stones for missions to Mars and beyond. One thing seems certain: before the end of this decade, we will see humans walking on the moon once again. This time, the goal extends far beyond national prestige and Cold War competition. The new lunar program focuses on scientific discovery, international cooperation, commercial development, and preparing for humanity's expansion throughout the solar system. The story of Apollo 11 reminds us that humans can achieve incredible things when we combine ambitious vision with dedicated effort and adequate resources. While conspiracy theories persist, the overwhelming evidence confirms that Neil Armstrong, Buzz Aldrin, and Michael Collins really did make that historic journey in 1969, inspiring generations of people around the world to pursue careers in science, technology, engineering, and mathematics. Their courage and NASA's technological achievement continue to motivate us today as we prepare for the next chapter of human space exploration. The moon is waiting for us to return, and this time, we're planning to stay.